The first one will be building OpenEBS operator from its source. OpenEBS operator is known as Maya, and I'm already in that repository. So it's in GitHub in the organization called OpenEBS, and the repo name is Maya. So this is my terminal, my laptop, and I'll just go through some of the things that is already installed in my laptop, which enables me to build the code that is build Maya from its source. So the first thing that I have got here is I've got a Go installed. And if you see, it's all installed, right? Okay. Now, if I do something called Vagrant, I also use Vagrant to launch a VM that in turn can also compile the source and also has a Minikube installed in it. I typically use the Minikube to do some sanity checks by installing the OpenEBS operator, that is mostly the Maya components, and running some volume provisioning. If we, currently we are in the folder in the directory where Maya is installed. This is typically the folder structure. And if I just go to the GitHub repository, which is here, so this is exactly the set of files which is being shown in my terminal. Now, there are some settings, some Git settings that I have done so that I can work on a feature, or that can be an enhancement, or maybe fix a bug. And this is what I try to do, what I've done. So one of the remotes that is, it's called origin. I've called it as an origin, and that points to the repo, which is nothing but Maya, that is forked from the user called Amit Kumar Das. That's my GitHub ID. So what I've done is I have forked Maya, and I have done a git clone of the forked project, right? And on top of it, I have added another remote called upstream, which is nothing but it points to the original, the source code of Maya, which is in the OpenEBS organization. And there are also some push and fetch related stuff where it says that you cannot, I cannot directly push the changes to the original repository. I can only push it to my fork, right? And from there, I will click on the PR button, that is pull request button, that will which will create a PR on the OpenEBS repository, right? Or on the Maya repository, which is in the steps. If one wants to get into all the steps, these are all available again in that same repository, OpenEBS Maya. Scroll down or navigate to the folder called docs, and once you get there, you have a file named as developer.md file. Click on that, and here goes all these steps, right? Whatever things I just repeated, one can find all of them mentioned here. Just go through them one by one, and you'll be able to repo in your own terminal in your laptop. So, okay, so once all these things are done, one has to check if the build is happening properly. So like I said, the first requisite is having Go installed, And the second one can follow the steps here to have the clone the repo clone into one's terminal. All right. I also talked about Vagrant, but that's not a mandatory thing. One can use Vagrant, one need not also use. That is also fine. So before going to the Vagrant, so what we'll do is we'll try to build the source, and for that we already have a make file. Let's just open up the make file. All right, so that we get some of the. I'll try to. I don't know. All right. I'm not sure. I hope this is visible. Okay, so one can see the makefile has got various settings which are set into different variables, and let's say some of the variables are mentioning about a set of tools that is required while running this build operation, right? If you scroll down a bit, we have a default target called all, and if that means if we just type in make, these are the targets, that is Maya CTL, the API server image, exporter image, Maya agent, all those things gets built, right? So these are the various targets. It's nothing but wrappers over typical Go commands, right? Let's say go test, and then if you see there is something called dep ensure. This is so Maya uses dep for vendoring, right? What else? These are some of the coverage related targets, and linting related ones, then some more linting here. Yeah. And okay, if one scrolls down further, one will find the use of Docker as a binary, right? So so the makefile has got some of the instructions, some of the targets, which has the ability to build Docker images as well. If one understands Docker and one reads through this particular line, it implies image called m-agent will be built with a tag named as CI, right? And it will also take in some of these build arguments, let's say date and all. Um, so the next requirement, if one has to build an image, right, of one of these binaries, right, Docker image of one of these binaries, that means the terminal or the setup needs to have Docker installed, right? So that is a second requirement apart from installing Go. Okay. These are the things that are there. Let me see if I have Docker installed. All right, so it's not installed. This is one of the new setups I have. However, what we will do is we will try to build the program, right? To build the program called Maya, and what we will do is we will run one of the targets. That target is here. So we'll try to do the make test, right? All right. So what we do is I call make test, and I'm not calling the default target here because I don't have all the requisites. For example, the Docker installed here. I'll do make test, and let's see if the program gets compiled and built properly. This will also run the Go unit tests as well. Right. Okay. So while this gets built, we can have some questions or answers, if at all there are any doubts, any queries.
Yeah, Amit, sorry, I joined late.
Yes,
what are you demoing?
So this demo is how to build the OpenEBS Maya from its source.
Oh, okay. Got it. Thank you.
Yeah. Okay. All right. So we were able to run the make test successfully. That means the package and the Maya repository is getting built. I'm just not running the SCSI SCSI issue. Okay, this is one of the real issues that we are facing in OpenEBS.
Okay. So yeah, so I've just called this the OpenEBS debug techniques session. So the agenda for this session is like it is motivated by the user's queries on the steps that are need to be followed to identify problems or bugs within OpenEBS or within any other dependencies in the environment. What are the logs that we have to collect? What are the recovery mechanisms to ensure that the application is back up, etc. So while responding to these queries on the users channel, we felt that it would be an appropriate thing to have these debug sessions as part of this contributor weekly meeting. We can do it. We can decide upon how often we would like to do this. But if we can have these sessions where we can discuss about what are some of the interesting and often seen issues, user issues with OpenEBS, then that will be really helpful for the community. And as part of this session, we will discuss how the issue actually manifests itself, what is the RCA that we have at this point, and the advantage of discussing it in the users community is we can have more opinions about what would have actually caused the issue, or like we can probably go ahead and get a better RCA, and what are the available fixes or workarounds that can ensure that we can get around the issue. And also this will help us get ideas on how to improve the debuggability aspect in OpenEBS. So that's the agenda of the debug session as such. So today's issue is an issue that we saw with one of our users, wherein a Grafana application which was being run with an OpenEBS PV showed inconsistency in data when it was deployed on different nodes. So this was very apparent with the Grafana users that were created, and it immediately showed up when the nodes were redeployed. So when I say that, when the first node saw a set of users, and when the pod went to the second node or another node, it would see that those users which were created on the first node were not visible here. This was seen on a multi-node cluster in GKE, and the GKE node version used was 1.7.11. So some of the additional notes that we got from the user with respect to the environment was OpenEBS PV was created on a storage pool. So this is the storage pool CRT, which we have been discussing in the previous session, where the pool was created over GPD disks attached directly to the Kubernetes nodes. The issue is being tracked as part of the number 1278 in the OpenEBS repo. We'll take a look at that issue in a bit and probably see what are the details recorded in that issue, and we will use that as a reference when we are doing the reproduction demo, which we will do in a bit. So this being the issue, we had some initial analysis and RCA on this issue, and this is what we found. So the Grafana application was getting redeployed, and the pod was basically getting rescheduled on different node as part of an upgrade. This upgrade was carried out automatically by using a deployment manager. In this case, it is wave flux. And each time the pod terminate happened on a node, the iSCSI volumes, that is the OpenEBS Jiva iSCSI volume, was not getting unmounted and the sessions were not being turned down. So this is something that is generally expected to happen with the iSCSI provisioner when using iSCSI for the PV. So what the result was, when the node was when the pod was redeployed onto another node, there was a fresh iSCSI login mount that happened on the new node. So for the sake of convenience, we're calling the initially deployed node as node 1 and the newly scheduled node as node 2. So in this case, when the pod moved to node 2, the Grafana pod, we saw that the iSCSI sessions were still present on node 1. This mount was still there. And iSCSI, not being a distributed storage protocol, mounts across nodes without using the appropriate reservation techniques can cause corruption. And the users that were created on the earlier node were not visible after the redeployment. So it is interesting to note that the first redeploy, that is the first time the pod moves to another node, the users are still seen because it's a fresh mount, but subsequent redeployments and movements of the pod can cause the issue to be manifested. So I'll just show you the YAML for the Grafana application that was being used, as also the storage pool and the storage class YAMLs that are being used in the environment. Before doing that, I'd just like to talk about some of the debug aids that helped us to identify the issue here. So the initial suspicion was around the OpenEBS replication, but when we reduced the number of replicas to 1 and tested, we got the same problem. And some of the tools which helped us, or some of the aids which helped us to get to this issue were the kubelet logs, which we got via the journal CTL command, and the commands for mount to see what are the volumes that are actually mounted and whether they're persisting even after pod termination, etc. The iSCSI ADM commands, iSCSI ADM and session to see session details, and -P3 to see the device to session linking, the fdes commands to see the disks, and we also used the Google SQLite viewer add-on for Google Drive to be able to view the content of the Grafana DB as we were writing. So this is something that I preferred using this to getting queries in the SQLite, but it can be done as well. And of course, we found some Kubernetes issues around the same problem, which talked about similar unmount not happening kind of cases. And some of these issues have been closed down due to inactivity, and some of them are still open. So this were the debug aids that helped us. The recovery involved on the same cluster. The recovery involved removing the stale mounts on the node in which the pod has already been terminated, and remounting it on the new node once again, and ensuring the application is restarted to consume the new mount. So this will ensure the data is backup and clean. And a workaround to this issue, to not see it, is to actually move to the newer Kubernetes versions. We have 1.8.7 GKE. These are the latest stable supported versions on GKE, and we found that with this version of Kubernetes, the issue is partially resolved. That is, we are seeing that the mounts are successfully gone. They are unmounted whenever the pod terminate happens. The iSCSI sessions are still there. That is something that is not decidable, but that is something we need to take up in the Kubernetes channels and follow up on the Kubernetes repo. But with respect to volume unmounts, they do happen in 1.8.7. And this is in a way sufficient to ensure that the inconsistency is not seen, that Grafana users are able to be seen successfully as and when they're created and as and when the pod is moved.
Karthik, one small question.
Yes, Vita?
Yeah, Karthik. So if I understand, there's inconsistency of number of records, but as such, there's no, I mean, it's not like invalid DB we never seen, right? We are seeing the users which are valid ones only. I mean, DB is not really corrupted, but so my question is it coming from the volume mount cache or how is it? The controller is still intact, replicas are still intact.
Yes,
Even though the new
you're right. You're right with respect to the data being actually present on the DB, but the inconsistency is coming from the mount cache. So when that is the reason why when we are doing the recovery step, that is unmounting on the stale node and remounting and restarting application on the scheduled nodes, enable the users created. But to continue this way, to have the mounts on both of the nodes can at some point result in corruption as and when the writes increase. We might overwrite the data that is already
so, so the one which you noticed is was mostly on the cache related thing. So we never got into the invalid DB kind of issue.
Right.
In terms of formatting, yeah. Okay. Thanks, Karthik. That's it. Thank
you. Yeah. So we'll go ahead and do a small demo, which is essentially a reproduction of the issue that we are describing. I'll take you through the demo artifacts, which we will shortly commit into the community repo, which like Amit has been doing. So we are creating a GKE cluster with 1.7.12. So the issue was originally seen on 1.7.11, but unfortunately now the latest supported versions or the ones that are supported for newly created clusters are from 1.7.12, but the issue is still does exist on 1.7.12, so we can show it on that cluster. Clusters have been created using Terraform templates, and these Terraform templates can be found in the E2E repo. So OpenEBS E2E Terraform GKE contains the procedure to create GKE clusters using Terraform templates. So we are using a variable file, which is basically holding the content of the various cluster config parameters. I will just show you here. So it needs the credentials for the default service account, compute engine service account, or any other service account which has adequate permission. And we can specify the version that we want using the variable here. I have selected 1.7.12, and I have the master username, password, and the machine type. I've used N1 standard 2 as the machine type, and I've used Ubuntu, which comes with the iSCSI initiator pre-installed. The actual Terraform file, which will be used, the HCL, that is the HashiCorp configuration language file, which is used to create the cluster, contains reference to the variables we defined in the variables.tf, and the initial node count and the min master version and node version will ensure that we have the cluster of our configuration. So in the interest of time, I have already created a cluster with version as 1.7.12 and another cluster with version 1.8.7, where the issue is partially resolved as we were talking. I will first go to the cluster in which the issue will be found, that is 1.7.12 GKE. So I have two nodes in the cluster, like we were saying, and I have already deployed the Grafana application. The YAMLs that are used can be found here. The first step in creating the environment, in creating the environment, is to first create the cluster, as we just discussed, and after that, the user said he's using a storage pool, and we have created a storage pool CRD by giving the path as MNT OpenEBS, and this path is basically a mount over a local GPD which has been attached to the nodes. So there's one GPD attached to each node. So this has been applied. this is present. So there is a storage class that was created for OpenEBS Grafana, which is referring to the storage pool that we created. And it is using the Jiva version 0.5.1. And this storage class is being referred to in the persistent volume claim of the Grafana application. So the mount is happening into varlib Grafana, if you notice here. And the persistent volume claim is called as Grafana claim, referring to the volume name Maya Grafana store. So the varlib Grafana is the location which contains the grafana.db. It also contains the session information for Grafana, and that is the data which we need to persist. So this is the persistent volume claim, which is referring to the OpenEBS Grafana storage class. So if you notice, so I have opened up the nodes here. So if you notice the nodes, PVC is actually created into the MNT OpenEBS repo. These are the two nodes. This is the current PVC that we have created. So the next step is to identify what node the Grafana is actually running on. And I'll do that using the -o wide command. So if you notice, the Maya Grafana pod is running on W4VQ, the node that ends with the hash W4VQ. So let me go ahead and create some users before we do that. And for that, I need to identify what port the Grafana service is actually running on. So it's running on a node port 32515. So I'm going to take the node IP and let me take the node IP. You could take any of these actually. The node port should be visible over both nodes. So we take the IP of this node. So let me log in into Grafana. I'm going to create some users. There's an admin user by default. Let me go ahead and create a few users. I have 3 users now. So generally, so there was one more suspicion that we had when we were debugging this issue. That was when we were doing some of the earlier tests, we found that the amount of time taken to sync the data that was written into a Jiva volume into the disk was taking a little bit of time. So we were actually suspecting the sync issue from the client pod, that is from the mount into the disk, as being one of the causes for the users not being found. But that wasn't the reason ultimately, as it turned out. So I have created 3 users, Amit, Vitta, and Kiran here. And I'm going to go ahead and simulate the action done by the deployment manager, which we just spoke about earlier when discussing about the RCA. I'm going to kill this pod and make it actually move to the other node. And I'm going to see whether the users are able to be seen there or no. But before doing that, I want to just show the existing iSCSI mounts. So this is the node that we saw where the Grafana was actually deployed. So I have already turned into root. I'm going to see whether the sessions are there. So this is the Jiva volume that was created after the PV was created, and this has been logged in into this node. So the disk corresponding to this session is SDB. So you see here that the volume has been logged in and the mount also will be present. It is generally present in the var lib kubelet pod path and then by mounted into the application. So you can see that this is the mount where device has been mounted. And these are the mounts which we are saying should go away when the pod is terminated, but are not. So now let's go to the other node, the node where it has not been deployed. You can see that here there will be no iSCSI session. There is no disk here, and the volumes also won't be mounted. There are some other pods here, which are other mounts here, which are respected to the, which are about the secrets being mounted for the Maya operator and other pods. Let me go and delete the pod as I was saying. So I'm going to take a chance here. I'm just going to delete the pod. Sometimes it is necessary to do a kubectl cordon of the current node to always push this node, always push this pod to the other node. I'm going to take a chance here and hope that kubectl delete is going to actually push this pod to the other node without me having to do the cordon steps. Okay. Okay. You can see that now Maya Grafana is actually running on the other node, the one whose hash is ending with VDK3. I'm going to go take a look at the corresponding node. This is the one. So now this is showing me the iSCSI volume that has appeared here. So also the disk, and the mount is going to reveal the same. We'll have the fresh mount. So you can see this device is now mounted here. So what happens on the other node when the pod is no longer present? So just to confirm, I'm going to actually confirm that Grafana is not running here. We know that. It isn't running. So ideally I shouldn't have the mount. But what we see is that this mount is still present here. So also the device. Okay, what is going to be the impact? Now let me go ahead and open Grafana. And okay, I'm going to just to eliminate the browser. I'm going to open up a new incognito windows every time I do this. I have some users here. Let me go ahead and create some more users here. So I've created the users here. And so one way to actually ensure that, to really check whether these are getting to, alluding to the question that Victor was asking, really seeing the corruption at the DP level or no, we can actually confirm that by getting this Grafana DB from the pod and executing some queries against it to see whether these users are already created or no. You can either run manual SQLite commands, or you can also download the SQLite viewer add-on and check that. So one thing you would have noticed that these three users, Amit, Victor, and Kiran, which we created on the node 1, are actually visible on the node 2. So this is because there is a fresh mount that has happened on node 2, and we are seeing this data. Now we have gone ahead and created some more users here. The question is whether these will be visible back when we move it back to the node 1. Okay, so now what I'm going to do is I'm going to kill the Grafana pod again and push it to the node 1. This is the pod, and we are running to push it into the other pod. Let's see if it is still successful. Okay, now Grafana has appeared on the other node. You can see the hash changed here. For the node, I'm going to go back to that node now. And so you would have seen that these are already there. But interestingly, there is one log which actually I forgot to show you last time around, which was about kubelet log telling that the session couldn't be turned on. So you can see these logs that it says that there has been a teardown. Sometimes we have seen logs which says that it has actually not been turned on, it is unsuccessful.
Have you seen the other node as well?
This is on report WQ. Before coming back and looking at this log on the other node, let me go take a look at what Grafana is actually telling me. Yeah, so you can see here that the new users we created, that is Karthik, Uday, and Prateek, which were created on the node 2, are not visible when it comes back onto the node 1. So this is caused because the volume was mounted in both the places. So before showing the recovery steps to see how exactly to retrieve those users here and how to resolve this, just want to show the same set of steps on the newer Kubernetes version on 1.8.7 and see how the users do reflect correctly and how the unknown does happen.
Yeah. Hi, Karthik. Amit here.
Yes, Amit.
Can we check the journal CTL logs on the other node?
Yes. Yeah. So this is the node 2. So these are the logs that we see where it does say that the amount has been succeeded, but it is actually one first log you see is for the secret, and the next one that you're seeing is actually for the PVC. But the amount has actually not happened, as you can see from here. So the Grafana is not running here now. But these mounts exist for the device. So we'll leave the setup for now, and I'm going to log into the cluster for 1.8.7 so as to not clutter my screen. I'm just going to close these nodes. Yes, Vita?
Can you hear me?
Yes, I can hear you.
So if the cache is the reason, which means the data is not going into the writes are also not going into the volume.
Vita, can you? I think your voice is breaking a little bit.
Okay. So the writes also are not going into the volume. The writes are not reaching controller.
Hello, Vita. Vita, can you also hear me?
Okay. I think we have some network problem. Probably. Okay. I can discuss later also on Blackboard.
Hi, Kiran, Vita. I think we are able to hear you. Maybe you can repeat your questions, or maybe write the questions on the chat window.
I think Vidya is asking the writes are not going to the Jiva volume. Is it the case?
So the writes are definitely going to the Jiva volume from node 2, but when the mount moved back to node 1, it's syncing whatever is data or it's part of the cache on the node 1. It's basically overwritten the data that was there on node 2, it seems like. Karthik, want to add something?
Yes, Kiran. So Vita, to answer your question, the write is actually happening. So that is what we were confirming by doing the Grafana dump.
Hello. Okay.
But the data is the one which is not reflected on node 1 because the mount is already existing.
Okay. So basically, reads are not happening onto the controller, but
Yes.
the writes are happening.
Yes.
Okay. Fine. Thanks.
Vita, just to understand, both reads and writes are happening to the controller.
Kiran, if reads are happening, you should have got the latest data, right, Kiran?
It is reading from the
cache of the node
cache on this one, right?
Yeah, right, correct. It's not into the controller, it's coming from this mount cache itself.
Right.
Okay. Thank you. Thanks.
So I have some nodes for the cluster with 1.7. I'm going to open those up now. And let me transition to the new cluster. So this is the new cluster. I have 3 nodes there, and I have cordoned off one of the nodes. I don't want to schedule it on that. So we are going to shift the Grafana pod between the first two nodes that you're seeing here, and they are 1.8.7. I have already defined, applied the Grafana pod here, and I have followed the same principle. There is a storage pool which creates the PV on MNT OpenEBS. It's on GPT. And we have the same Grafana storage class here, which is referred to by the Grafana PVC. So there are some users that are already created here. So I'll directly go ahead and show. Let me open up that Grafana. It's on 32025. And so let me look at the users that I have created here. There are quite a few users which are already created. So these are the result of the tests that we performed earlier. So let me look at the nodes on which the Grafana is currently scheduled. So you can see Grafana is actually sitting on this node now. So let me go take a look at that node. So this is the one. Let's look at the same set of commands. So there is a ISQC session here, and the mount is also present with that. Device is SDC. So now let me do the same thing on the other node. Still trying to connect. So the session is present. So this is what we were talking about in 1.8.7, where the sessions are not turned down, but the mounts are not present. So let me show that. So the only mount that we have here is the GPT that is mounted on MNT OpenEBS for storage pool. We do not have the ISQC portion. Let me go ahead and create some users, new users. Pardon me for the usernames and passwords and names. Not able to think any better now. So I have created two new users, contrib1 and contrib2, that is created on the Grafana, and it is residing in this node now. So I'm going to force a delete of the pod. And push it to the other node. So here again, I'm not going to call down. And I hope it moves to the other node. Okay, you see that it is now, this is moved into the other node. The hash has changed. I'm going to confirm this by doing proposition. And meanwhile, let's also go take a look whether these mounts persist. So this is the node from which we removed it. So if you see, the volume mounts are not present. The mounts that you see are for the secrets of the operator pod, which is also residing on this node. But the mounts for the device are not present now. Okay, so we can see the contrib 1 and contrib 2 are present. These are users we created on the node 2, and it's now visible on node 1 after we have moved it. So we saw this happening for one iteration on the order cluster as well. So though we have done a few iterations just for the sake of the demo, let us go ahead and create some new users while it is on the other node from 1G32. And to show that it is actually available here now, because there the device is actually present here. So this is 1G32. I'm going to create some new users again. We are using users as the convenient method for showing this problem because it's something that's most easily apparent, but this will not be applicable to any kind of data.
Karthik,
Yes,
can you switch to that mount window, the shellware?
Yeah.
So just, I think Vita raised a good point, and that the reads are happening from the mount cache, and that's why we are not getting the actual data that got written to the disk. And then later on, the current state get cached, and we kind of maybe lose the data as well.
Yes.
Thinking aloud, are there any other mount options that we can set when mounting this iSCSI volume? We can avoid this kind of caching issues.
Yeah, probably we will have to ensure that when the provisioner is mounting the volume into the nodes, we can sort of force it to mount by using not using cache. There should be mount option for no cache. Vita, is that a correct understanding?
Yes, Kiran. Yeah. So without caching options, right?
Correct.
Correct. Yeah, that should also, yeah. And also I'm thinking like this being Kubernetes issue for sure. Yeah, as you told, we need to have a way of from our side, so we can have allow only one login or like portal groups. I'm not sure how to currently.
Yeah. So I'll just probably come to that in a second. Kiran has raised a few issues wherein we are talking about using the component Maya nodebot to ensure that whenever these unmounts are happening, whenever these spot terminates are happening, we have to force the unmount and ensure that there are no multiple mounts maintained. Also, from a debuggability perspective, to ensure that whether to see how many guys have mounted, how many guys have logged in into this volume currently. whether we can retrieve that information from Maya, CTL, or no, and whether we can instrument our logging in the controller logs or to record these.
Yeah, and also I think the ISKC PV supports because we use Kubernetes ISKC PV, it supports passing some mount options as argument. I think it will set it. We can actually, uh, you know,
I think iSCSI do have nothing to do here, Kiran. iSCSI D is just a discretion. After the discretion, we have this mount comes in, right? I think
Uh,
the Kubernetes,
that's the
whatever
one
that.
Kiran is mentioning.
Sorry.
And I think right, correct. I think that is what Kiran is mentioning.
Oh, okay.
When
Okay.
we are doing the mount, whenever the kubelet or like currently, I think that we have an option in the provisioner, ISKC provisioner, where we are passing the format type, etc., and the
Oh,
basic
okay.
mount options for mounting into the nodes.
Oh,
So,
okay. Cool. It's in our control. Okay. Okay. Good. Okay.
Hi,
Got it.
this is Ganesh. So I have a question like, can you hear me?
yes,
Ganesh.
Ganesh.
Yeah, so this node bot is going to give information about the node name, right? Where the storage pool is going to be created. Right now, we have created the storage pool with a YAML file applied manually. So if nodebot is going to give the node name on where the storage pool is going to be created, we can have the Maya designed with some node affinity or somewhere, right? So if it is going to be designed like this, then we can avoid the probability. Is what I feel. Am I correct? Maybe we will be losing some features of node failure than rescheduling. That is the only case, but we can avoid the pod failure, right? We are going to fix it to work on particular node.
He's
The
right,
pods.
little bit right. If the pod is not scheduled to other node, then this issue will be reduced. Yeah.
So just to answer that question, yes, I think it's a good suggestion, Ganesh. We need to schedule the pods to the nodes where the pool is available via hooking into the node bot when it comes up.
Okay.
That's definitely one thing that we will be looking in the next release. In addition to that, I think this issue is mostly related to the mount. Even if it is on the same node or getting mounted from a different node, we will still have multiple mounts cache problem. So we need to fix that as well.
Oh, within same node we'll have this problem. Karthik, did you try that?
Can you come again, Kiran? Can you just repeat?
Yeah, so I think even if you localize the controller to be on only the set of node, because the pod will move across at least like 2-3 nodes wherever the storage pool is there, you will end up with multiple mount options being there, multiple mounts being present.
Right. Yes, that's true.
No, within same node he's saying.
This is
So, Ganesh, are you saying if the application pod shouldn't be moved to any other node and has to be pinned to the same node?
No, I'm saying like, yeah, not pinned to the same node in the sense that we are providing one information called, in the storage pool we are creating, the node name where the storage pool should be created, we are providing. So I'm asking like, if it is going to be pinned to the same node, we are going to, we are going to avoid the pod failure. We can't avoid the node failure. So we can, that's what I tried to say it, but Kiran said like, even if it is in same node, we may face this mount cache issue. So I asked Kiran like whether within same node we'll face this issue or only between the nodes we'll be facing the issue.
This is okay. This is going to be between the nodes because if you're on the same node, you are not going to be doing a remount. You're going to be using the same mount. So that should be okay, but I don't think it is going to be feasible to ensure the application is going to reside on the same node always. I think that will be an anti-pattern for Kubernetes.
Okay. Maybe we can.
Yeah. So the replicas being pinned to the same node, I think that is a fair understanding. So storage pool to create the replica where the storage pools are there and not move out like the way the OpenEBS scheduler is being worked. I think that is
I'm not. Yeah. Okay. I get your point. So I'm not saying like we can pin to the same node, except that we can go for this soft node affinity or something.
Okay. Okay. Yeah. So I think it's in the discussion of the application admin, not the user, where if they can use a node selector for their application, he can ensure it is always coming up on the same node.
Okay. 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 Thank you.
Okay, just another thought on the same one. If you have some time, we have some time. I think we are shooting.
Yes. Go ahead, Vitas.
Okay, so probably Nodebot can be monitoring the amounts of our own, and then can do some kind of okay. It's now there is another one. There is multiple of them, and then try to close them or something like that.
Yeah. So let me open up the issue which I think Kiran has raised. Okay, this is about the Maya CTL to show from the debuggability aspect. This is the Nodebot related one which we are discussing. Okay.
Okay. Yeah, this makes sense. Yeah. Yeah. Cool. This is what I meant. Yeah. Cool. Good. Thanks, Kiran. Yes.
Okay, so we'll just come back once again to this to see what are the Kubernetes and OpenEBS issues tying to the problem we are discussing, just for our reference later. Meanwhile, just to show that what we were reinforcing, the new users are present here, unlike with the older cluster. And also on the node from where we have removed it, the mount is not present. I was saying that these mounts are all for the secret mount for the operator pod, which is scheduled also on this node. So this is on 1.8.7, where we don't see the issue. And coming back to the recovery step that we were discussing, I can go back to the slides. So we showed the workaround. The recovery, I think, probably I'll skip that in the interest of time, but the recovery step, what we were going to do is like whatever discussion was just happening with Ganesh and Kiran and ourselves. So we can go ahead and ensure that the unmounts are manually forced on the stale nodes from where it has been removed, the pod, and remount it on the current node to ensure that you are seeing the correct data, the fresh data. And you have to restart the pod also to use the fresh mount that we have made. And that can be done either using a kubectl delete pod again, like we did, but it has to be brought up on the same node so we can ensure a few steps like ordering of other nodes. Or another way is to actually do Docker stop of the application on that node. Docker stop, if you do, then kubelet will go ahead and manually restart it back on the same node. That will use the fresh mount that we have made, and the data can be visible. So that's the recovery that was talked about. I'm just going to show once again all the users that are associated with this problem. So we saw the logs and the commands that are used in this debug aids. These are some of the issues. 42889 is one of the issues that I can show. This is one of the issues that helped us to identify that such a problem can exist and Kubernetes is behaving this way. So the difference here is that it has made use of a containerized kubelet, and in our case in GKE we are not using a containerized kubelet. but the issue seems to persist. One other thing to note is when the same test was repeated on the same Kubernetes version on a local cluster, which we actually created using kubeadm on some ESX VMs, we did not see the iSCSI sessions persisting as well. So this could be an issue which is specific to GKE, but we need some more data before we can conclude anything like that. But just for reference, there are some issues around amounts not happening successfully. This is one of them, 42889.
Hi, Karthik. Amit here.
Yes, Amit.
So the issues that you're referring now,
yeah,
has it been referred from the OpenEBS issue that we see?
Yeah, so we have referred to this issue 42889 in our issue as well. So all the logs that we just discussed have been placed here for reference. So we have referred to the Kubernetes issue here. And let me just check the 42889.
Okay. Today's session.
Okay, let me check if 42889 has not been referred. I will go ahead and add that. I think we've referred to some of the other issues here, which Kiran had raised. There are some more issues in Kubernetes which are talking about this, but some of them are not related to iSCSI. For example, there is 41096. There is also 32336, where the case is with an RBD volume. So here it is interesting to see that they're talking about volumes that are not in the purview of the attached controller, which are facing this issue. So that is something we also have to investigate further. And probably an issue can be raised in the Kubernetes repo detailing the problem here. Meanwhile, if any of the interested users have any info about this or are asking around in the community, then you can also update the issue with your findings into this issue. Yeah, so that's about debugging this problem. Probably in the subsequent sessions, we can try and come up with more issues that the users are facing, and we can probably have similar discussions around the RCA and the potential workarounds and fixes for those issues. I think that's it from me. Any more questions?
Thank you, Karthik. This was excellent. I learned quite a bit from your session today. Thank you.
Karthik, can you post this links on the Slack channel?
Sure. So the slides are available in the contributor weekly agenda document. The slides have been updated there. The Terraform files which we use to create the cluster and the other tools that I mentioned and the issue references, I probably also add them into the community demo page in the repo.
Okay.
And I'll also share it on the Slack channel. Thanks.
Thanks everyone for